Assalamualaikum warahmatullahi wabarakatuh and a very good day to our respected panel. We are from Group 13, Section 1. Would like to present our project, which is the Smart Shop. The team members are myself, Siti Asmah, Muhammad Fakri, Muhammad Lukman Hasif and Muhammad Nazmi. The problem statement of this project is the first one is according to ResearchGate January 2015, most people spend around 20 to 30 minutes per day shopping for household necessities. The second one, according to World Health Organization 2020, for communities, inadequate shelter and overcrowding are major factors in the transmission of diseases with epidemic potential. Outbreaks of diseases are more frequent and more severe when the population density is high. And the last one is according to a new survey by Bankrate.com, 72% of respondents still taking trips to the grocery store amid the pandemic rather than using delivery services. This is because of the numerous issues people are experiencing with the grocery delivery services, such as items out of stock, high service fees, late delivery arrival, groceries lacking quality and freshness, also a delivery being cancelled or never arriving. Hence, the objective of this project are to design a robotic cart that could automatically move to designated place, to integrate the robotic cart with application, and to develop an application that allow customers to order items without going into the traditional store. The overview of this project are the customer will order the items through the application and the employee will receive the information from the application and they will place the items into the robotic cart. The robotic cart will move to the drive-through or pickup counter according to the customer's preferences and the customer will receive the notification to pick up the items when their order items are ready. The next customer will drive to our smart shop and they will receive their ordered items. Our smart shop is based on the NABC concept. Needs. This project is needed to spend less time on grocery shopping to avoid long queuing, especially for reduced mobility people such as elderly or pregnant ladies, and to avoid going into crowded places, especially during this COVID-19 pandemic. For the approach, we use infrared sensor module as line detecting sensor and a simple application for customer to order items. The benefits of this smart shop is to reduce long queue, time saving and less manpower required. As for the competition, we have a drive-through feature for a more convenient shopping process and this smart shop requires smaller space than the current grocery retails. That's all from me. I will pass to the next presenter.
Present the simulation of our project. The simulation of our project is built using Tinkercad. The simulation is performed to simulate our project virtually before the prototype is built. So this is the project in Tinkercad. This is the Arduino Uno, breadboard, 2 DC motor, HP motor driver, and 2 IR sensor. The importance of the simulation is to ensure our project will function according to what has been proposed by us. It is important to take note that the simulation is being done before our group decided that the Raspberry Pi will replace the Arduino Uno R3 as the microcontroller. The reason for the change is because the Raspberry Pi has Wi-Fi module that already integrated in it. This Wi-Fi module is important for the IoT part of our project. Hence, the Raspberry Pi is chosen by us as the microcontroller instead of Arduino Uno, that will have Wi-Fi module that integrated in it. Although the simulation that has been done is using the Arduino Uno as the microcontroller, the simulation still exhibits the working of our project. So now I will start the simulation. As you can see, the DC motor rotate. The right and left DC motor rotate at the same value of the RPM, which is 9393 RPM. This means that the robot can't move forward as both DC motor rotate at the same RPM value. Unfortunately, The simulation could only show the robot cart moving forward due to the limitation of the component interconnect. The simulation like the IR sensor model, DS just IR sensor. The IR sensor model have a LED and photodiode. The simulation also like the L293D motor driver that the robot cart need to reset to turn left and right. The robot cart will turn left when the value for the right motor is less than the left motor, and to the right, the value of M for the simulation, the left motor should be less than the right motor. The simulation could be done better by with the MCO that has been improved in Malaysia. Our group cannot build the prototype together. Hence, our group decided to focus on the coding and building the prototype.
Hi and Assalamualaikum. My name is Muhammad Lukman Hasib bin Muhammad Jasni. Today I will demonstrate our project, which is Smart Shop, the robotic cart. So first I want to demonstrate our application and database. So here is our application. So first we need to fill in our name and our phone number. Then we go to cart section. So we will fill in the quantity of item we want. So item 1 I want 0, and item 2 2, item 3 0, and item 4 is 1. So let's proceed. So here we will pick the method, which is drive-through or shop counter. So I will pick drive-through. So as you can see here, the database was changed according to the app. So our database will send the data to our Raspberry Pi. Then when the Raspberry Pi has finished the process, the Raspberry Pi will write empty into the database. So the database will reset as before. So that's all for database and application. So next I will explain about the RFID module. For RFID, I have load write program into Raspberry Pi. So now I will load item 2 and write into the RFID card. So it has write my RFID card. So then I will load read file into my RFID card. So again, item 2 I scan into the RFID card. So it has successfully write and read my RFID card. For my IR module sensor, I have loaded my program into the Raspberry Pi. So the IR module sensor is to detect the line. So I am using white line in this case. So if the IR module sensor detect both right and left was black, so it will move forward. Then if both is white, so it will stop. Then if it was right or left, so it will move the motor to move right or left. So I will run the program. by manipulating the IR model sensor, I can make the robotic cart turn into intelligent. Now we will run our program. So first we will fill in our app. So first we will enter name and phone number. Then di card section I choose item 1 is 0, item 2 is 2, item 3 is 0, and item 4 is 1. So then next I will select drive through or shop counter. So if I press either one of these, so it will start the robotic cart. So I will skip for a while to explain about the robotic cart movement. So the robotic cart movement, it will follow the line, white line, based on the IR model sensor. So then if the robotic cart scan the RFID card, so it will determine is the station to stop or not. So in this case the robotic cart will stop at item 2, item 4, and drive through. So for this example, I will only use item 2. So let's start the demonstration. So here the IR module is to control the movement of the robotic cart. So if I close it will stop, and then if I open either one of these IR module sensor, it will turn right or turn left. Then if I scan RFID card item 2, so it will stop for a moment for the time to give the time for the shopkeeper to put things into the card. So the robotic cart will stop when it reaches the end. For the demonstration, I will only use a straight line because I was in college, so the space is limited. So I can only show only a straight line for this demonstration. Now we will start our demonstration. So from left, it was item 1, item 2, item 3, item 4, drive through, pick up, and start or finish. So the input for the app was the same as the previous. So it will stop at item 2, item 4, and drive through. Then it will go to finish. So at finish, it will clear the database and it will start getting the database input again. So let's start our demonstration. So it stopped at item 2. So it will wait for the user to put the things in the cart. I'm really sorry for the problem. The motor before this is working well, but during demonstration it suddenly not working. So here I will provide proof that the motor is working before the demonstration. Again, sorry for the problem. So that's all from demonstration part. Thank you.